All right, so we talked about critical values. What is a confidence interval? So if we're going to do a confidence interval for a mean, x bar plus or minus z star times the standard error of x bar, okay, which is really the standard deviation. What if it's categorical? It's going to be p hat plus or minus z star times the standard error of p hat. So that's going to be our next focus. How do we come up with these standard errors? So let's take a look at a one sample z interval for a population proportion p hat. So the z star is the critical value we just talked about. So p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. This is the formula for the confidence interval. P hat plus or minus z star times the square root of p hat times 1 minus p hat all over n. Okay? Where z star is the critical value. It gives us the multiplier, how wide our interval is going to be, based off of how confident we want to be that we capture the true population parameter. Now, in order to construct a confidence interval, we have to make sure that we're going to call these conditions, that our conditions have been met, meaning the data must come from an SRS. There's no way to fix bad data. If we don't get data from an SRS, then we're just polishing a turd. Okay, we just got a shiny piece of crap and we're done. Okay. Then they talk about this 10% condition. So that's independent. Okay. So we have SRS, independence. Is the data independent? If it's not independent, then we cannot trust our confidence interval. What this is saying here is that the population must be at least 10 times the size of the sample. And then down here is large counts. What they're asking us is check to make sure the data is normal. Okay, so if n times p hat and n times 1 minus p hat are both greater than or equal to 10, then the data is approximately normal. So we need to check these three conditions for every single confidence interval that we construct. Did the data come from an SRS? Is it independent, meaning the sample is at least 10 times, the population is at least 10 times the size of the sample? And is the data normal? So can we use our z-score table or this new table B that we just looked at to find our critical value z star? Okay. So super important. Step one, explain what we're going to do. Step two, check the conditions. Are we allowed to do it? Step three, do it. Step four, tell us what the heck we did. Okay. Now we're going to talk, I've referred to this standard error. The standard error is everything behind the star. So everything behind the star, standard error, everything behind the star. What star? Everything behind Z star, or as we'll see in some of the other ones later, everything behind T star. So the standard error is everything behind the star. The margin of error is everything behind the plus and minus, and the point estimate is everything in front of the plus and minus. So calculating critical values. Okay. We spent a lot of time already calculating critical values on the previous slide. That's where if we wanted to be 90% confident or 95% confident, we could use table A and look those up. So I got ahead of myself and forgot to use the slide that was made here for it. All right. Let's do a problem from beginning to end, a complete 4-step process for every single confidence interval in the world. So first, state the parameter you want to estimate and the confidence level. So step one, okay, what are we going to do? Step two, identify the inference method and check conditions. Are we allowed to do it? Step three, do it. And step four, interpret what we did. Okay, so let's go through this process right now. A A recent poll of 738 randomly selected cell phone users found that 170 of them admitted to walking into something while talking on their cell phone. Construct and interpret a 95% confidence interval for the proportion of all cell phone users who would admit to walking into something while talking on their phone. Okay, so first, what are we going to do? Okay, so step one, I'm going to label this out here for us. Step one, what is it that we want to do? Okay, we want to construct a 95% confidence interval. We want a 95% confidence interval for what? The true proportion of what is our population of interest? What are we trying to find? The true proportion of all cell phone users who admit walking into something while talking on their phone. So we need to say, what is it that we want to do? Oh, I want to find the true population proportion, all cell phone users in the entire country who would admit doing this. Okay. Sorry for my poor writing here. I'm getting better, but it's still pretty ugly. Identify the appropriate method, okay, and check conditions. Well, what are we going to do? We are going to make a one sample Z interval. Okay. Let's check conditions. Are we allowed to do this? Where did the data come from? So in order to check conditions, the first condition we need to have to check is SRS. Did this data come from an SRS? Well, it tells us a recent poll of 738 randomly selected cell phone users. So the data was random. The only way to check for SRS is, does it tell us or not? We don't know how the data was gathered. They have to tell us. So SRS random, yeah, sounds like the data was gathered randomly. So therefore we can probably trust this value. Okay. The second one we said was independence, which the book states as the 10% rule. So there are certainly more than 7,380 cell phone users. So we're safe there. Right? The data is independent because the population is at least 10 times the size of the sample. There's definitely more than 7,380 cell phone users in the United States. And then we need to check normality. Okay? How do we check normality? Does n times p hat and n times 1 minus p hat, are they both greater than or equal to 10? Well, n is 738. Okay. What is p hat? Well, I don't know. I need to calculate p hat. Okay. P hat is 170 over 738. And 738 times 1 minus 170 over 738. I need to multiply those and see that they're both greater than or equal to 10. Okay. So this would be 568, certainly greater than 10. And then this value here would be what is that, 178? Certainly both of those are greater than or equal to 10. So we're allowed to do the problem. Okay? What kind of problem? One sample Z interval. Is it okay to do it? Well, the data was random. It's independent because the population is at least 10 times the size of the sample. And it's approximately normal because n times p hat and n times 1 minus p hat are both greater than or equal to 10. Well, now let's do it. Let's construct the interval. So we have p hat plus or minus z star times the standard error. So in this case, p hat is going to be 170 divided by 738, which works out to be 0.23. So our point estimate is 0.23. Plus or minus z star. I want to be 95% confident. So let's go to table B and let's look. 95% confident. Oh, that's 1.96. So I don't have to do the work. I just got to look it up in the table. So my multiplier or my critical value is 1.96 times the square root of p hat times 1 minus p hat all over n. So that's going to give me 0.23 plus or minus approximately 0.03. So if I type this into my calculator, my margin of error is roughly 3%. So finally, I can finish this up. My confidence interval goes from 0.2 to 0.26. I am 95% confident that the true proportion of all cell phone users who admit to walking into something while on their phone is between 20 and 26%. Okay? So 4, but I need to put it in context. I am 95% confident the true proportion, trying to squeeze this in here, I'm running out of space, of all cell phone users who admit to walking in to something is between 20 and 26%. This is the same process that we're going to use for every single confidence interval. The nuts and bolts, the calculations are going to change. How we check the conditions might differ depending on the problem. However, the process is going to be the same. What are we going to do? Are we allowed to do it? Do it, and then tell us what it means.